Hi, hello friends, welcome to the channel MS Mechanical. In this today's lecture, we are going to see how to find stress and strain for tapered sections. Okay. Now this is for tapered rod. Okay. This is for tapered rod. There is a tapered section. What is tapered section? A rod having different diameters is called a tapered section. Let the diameter d1, this be d2, and this be length L. There is a force acting, P, tensile. Okay, what happens? There is stress and strain. Okay, how to find stress and strain? We'll consider a small area B dx. This is at a distance of x from this left end. This is left end. This is right end. Okay, let this be x. Does dx be at a distance of x from the left hand? We'll decide it. Okay, we are going to find the stress and strain in this area, and we will get the whole stress and strain. How to find the whole tapered piece? We know the diameter here be d1 and the diameter here is d2. What will be the diameter in this tapered? This dx area will be dx is equal to, we can write this as capital D1. Okay, capital D1, small d1, that is not making a big difference. D1 minus D1 minus D2 divided by L into x. Okay, this is the expression. This is the expression to find the diameter of this place. The big diameter d1 minus small d1 divided by whole length into x. X is the distance from here. Now this dx, we can write this whole term as k. We will take this whole term as k. What is k? What is k? Kb d1 minus d2 by L. Okay, let disturb, yeah. Okay, I'll wrap and write here. Expression for dx is equal to d1 minus d2 divided by L into x. Okay, we can write dx, will take this whole term as k, leaving this x, therefore d1 minus kx. What will be the area in this section dx? What will be the area in the section dx? Area of the section dx be pi by 4 dx square. Okay, we know that the area of the section be pi by 4 into dx square. We can write this as pi by 4 into d1 minus kx square. Okay, yeah, we can write this as pi by 4 into kx square. Now we know stress is equal to load by area. You can write this as P by load divided by pi by 4 into d1 kx the whole square. This we can write it as 4p by pi into d1 minus kx the whole square. This is the expression for sigma. What is then strain? Strain we know as stress by Young's modulus, and we can write this as 4p pi e into d1 minus kx the whole square. This is for strain of the whole length. Then what is the strain of the length dx be? The strain of the length dx will be, if there is strain in the whole tapered rod, there will be strain in this particular portion also. So the strain in this particular portion will be Ex is equal to 4p by pi E into d1 minus kx, wait a minute, into Ex dx. Okay, this I don't know. The elongation in this portion will be due to tensile load will be Ex into dx. You know Ex term as 4p by pi E into d1 minus kx the whole square into dx. If we integrate this whole term, we get dl as integrating from 0 to L. Take this as 0 and this L. This whole length is L, right? This whole term is L. So we can write this as 0 to L. If we integrate this whole term, from 0 to L, we get dl is equal to 4p divided by pi ek into 1 minus d1 into k into L minus 1 by d1. We get this expression. We know k is equal to d1 minus d2 divided by L. We know k is equal to d1 minus d2 divided by L. Substituting in that equation, if we substitute and evaluate that equation, we get a equation as change in length be 4pl divided by pi e into d1 d2, or we can write this as 4pl divided by pi e d square. This is the expression for change in length in that particular area. Change in length for the whole taper rod. This is the change in length of the whole taper rod, and change in length for a strain, you will find, if you take this L to the bottom, you will get the expression for strain 4p by pi e d square If you take the Young's modulus there, you get the stress 4p by pi d square. This is equal to strain. Okay, you have to memorize this 3 formulas very carefully and very keenly. Okay, today's class is over. Thank you guys. Bye.